Figure 7.17 InitArray.java. In this example, we're going to create a couple of two-dimensional arrays and show you that the same function or the same method can use a nested for loop to process both of the arrays, even though one of the arrays has the same number of elements in every row and the other array has a different number of elements in every row. So let's start out in our main method by taking a look at our array declarations. This first array declaration indicates that array 1 is a two-dimensional array, and we have two sublists in the main initializer list. Therefore, this two-dimensional array has two rows. The first row has three columns as specified by the first sublist, and the second row has three columns as specified by the second sublist. Array 2 is also a two-dimensional array, but it has three sublists inside the main initializer list. Therefore, it has three rows. The first row has two columns, 1 and 2. The second row has a single column, 3. And the third row has three columns, 4, 5, and 6. And now what we're going to do in main is print out a heading for each of our arrays and then call the output array method with each array so that you can see that one method is capable of recognizing the proper number of rows and columns in each of these arrays. So we begin by outputting the values in array 1 by row, and then we call output array to do that for array 1, and we do the same thing for values in array 2 by row, and we show you here the call to output array with array 2 as an argument. Now if you take a look at the output array method, you'll see here that it receives as its argument a variable called array for the parameter name. It's of type int, and it represents a two-dimensional array of integers. Nothing is specified here about how many rows or columns there are, nor do we need to specify anything, because every multi-dimensional array is really an array of one-dimensional arrays, and every one-dimensional array knows its own length. So take a look at how we deal with this. It's very common to use a nested for structure to iterate through a multi-dimensional array, especially a two-dimensional array. So we start with a for structure that worries about which row we're looking at, and we have a counter called row which starts at 0 and keeps iterating as long as row is less than array.length. When you take the array name of the parameter, the parameter name, and use .length on that parameter, it gets the length of the first dimension of the array that we received as an argument. And this is therefore going to iterate through however many rows there are. In the case of array 1, it will be 2 rows based on these initializers, and in the case of array 2, it will be 3 rows. The more interesting loop is the nested for loop here at lines 26 and 27, which is going to walk through the columns of a given row. And the most interesting part is this condition, where we're saying as long as the column is less than array sub row dot length. Array sub row is one element in the first dimension that picks off which row you want to look at. Dot length tells you the length of just that row, and that's where the interesting part is, because if the row is in a jagged array, this expression is going to give me a different value each time I move to another row. And regardless of how many elements there are in each row, how many columns there are in each row, we still pick off the values the same way by taking the name of the array followed by first the row index and then the column index. When I say array sub row, that moves me to the one-dimensional array that represents a particular row's columns. And then when I say sub column, that moves me to the particular element in that array that represents the columns. And I then pick off that value and display it with my printf. And after I've done the nested loop, which does one row of the multi-dimensional array, I print a new line character to start the next line of output. So if I go back up here and I say to run my project, we can see in the output down here that the values in array 1 by row are 1, 2, 3, 4, 5, and 6. And similarly down here for array 2, you see that we did indeed get 3 rows. The first row has 2 columns, the second row has 1 column, and the third row has 3 columns. Now it's extremely important to point out again what we're doing here to figure out the number of columns in each row. If you were to assume that all the rows had the same column and hard code some number there, such as 3 for the number of elements in a column, that's going to result in the first call to output array working properly because each row has 3 columns. But in the second array, as soon as we try to output the third column in the first row, we're going to get an array index out of bounds exception if we hard code the number 3 here. So you do have to be careful, but you are able to write a single method that is capable of processing all two-dimensional arrays, in this case, to output their values.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.